Hello, my friends. I have had all sorts of technical difficulties, but that's what happens when you start on new software, new programming. That's the nature of it. I like to sort of say when things are hard, bless them for being hard, because if it was easy, everyone would do it. So, whatever you're setting up, whatever path you set for yourself, if you find it a bit challenging, bless the challenge. So I apologize for being a bit late today due to my technical difficulties. It did take me some time and it's still not quite working the way that I would like or intended it to. And that said, I'm going to go ahead and do a tech check because in the past I've had some sound issues that have made my videos unwatchable. I was really upset that I had done what I thought was one of my better content. I had lighting, I had the set, I had the content. I was really pleased with everything about it, and then when I went back and reviewed it, the sound was unwatchable. So it is January 9th, and I took the weekend off, but before that I had a week of live streams every day. I've been streaming at 12:30 focused on data science, and at 9:30 focused on my support for Ukraine, and that has been kind of my rhythm. But I have been plagued with technical difficulties. But every day I improve. Like I bought a new camera, and then the old camera just decided not to work today. So I was switched out the main camera versus the secondary. I am wanting to add a different sound input, but the software is not recognizing it. So what I'm doing right now, bear with me a moment, is I'm just gonna run over to YouTube. I'm going to pull up my live stream and we're just going to do a quick sound check. So that's my goal here is it tells me I'm live. So what I'm doing right now, just bear with me a moment, is I'm just going to run over to YouTube. I'm going to pull up my live stream and we're just going to do a... All right, sound check sounds good. So sound check. Okay, so we're going to continue where we left off last time. So a couple things. So what we're doing here and what all these live streams are about, again, I'm going to do my best to be as consistent as I can about being here every day at 12:30 Eastern. And what we're doing in this live stream is we are learning data science together, and we're specifically starting with Python coding, and that programming language. I come to this knowing a bit of R, but I just saw that Google had this free course that was based on a 2-day internal course that they do, and they have made it creative Google's recommending them for this course because they're really trying to put it out there as a whole sort of free program. So if you're looking for free ones, definitely follow along with what Google is recommending here, but also, or look up others and see what you want to, or like Visual Code Studio remains an option. But I'm going to go ahead and I downloaded, and now I want to open up and experiment over this week with PyCharm and see how I do with that one. So there are some exercises in this course, which I've downloaded the files, and all of the links are both in my videos and on this link for the Python Google course. What we're going to do today is just lean in and go ahead and watch the second video. It's 35 minutes, so I will be here with you as we go ahead and watch that video. So the last video we looked at was the introduction to this whole program and strings, and this one's now going to look at lists and sortings. So I'm going to kind of change it up a bit, because last time what I did is I went through the articles first and then I turned on the video, and I wasn't sure where to put in the exercises, but then I realized I didn't have the right interpreter for the exercises. So what I'm going to do today is just play the video. That's going to end our day today. I'll be back here tomorrow at 12:30 p.m. and we will do our next stream, and we're going to then, we'll probably start looking at the articles and just kind of review what the video said. And I will also be pulling up PyCharm and other interpreters, and we'll just kind of go through the interpreters together and see which one we choose before we begin to tackle the exercises. So that's what we've got going on today. So I'm going to go ahead and play the video. And I am here. Yep, there we go. So I'm going to go ahead and video, and let me so I can go over here.
Stop for the days on lists and tuples. One of the set of little exercises about that, and then I'll finish off talking about dictionaries and file. And then we'll have a large exercise, and that'll complete the day. So that's it. I'll get you out of here around, I don't know, 4:15, something like that. All right, so let's talk about another Python type. So let's fire up the interpreter here. So I did strings. So the next type I want to show you is the list. So the list is in up here. I wanted a list of like the numbers 1, 2, 3. That would look like that. I can assign it into a variable to make it very much like my last example. The elements, very often they're all the same type, but there's no requirement. So I could have like 1, 2, and then like a, oops, okay. What's the problem? Oh, too many commas, that's right. So if you have a list of different types. In reality, mostly you'll have a list of all the same thing for just, this is just sort of the most intuitive case. Now, Python has this sort of design idea that instead of having, one syntax for strings and another syntax for lists and whatever, Python tries to use the one syntax very consistently for all things. And so this is a nice quality. It means when you're learning it, there's less to memorize. So for example, the length function for lists is just the one we learned before. So I could say len of a, just like for a string. And in fact, many of the bits of syntax or operations for strings work on lists as well. And so Python sort of deliberately could do a plus. So I could say, well, I have the list 1, 2, AAA, plus the list, 3, 4. And like puts it together to make a bigger string. With lists, it like puts them together to make a bigger list. So one difference that lists have, here I'll set this back to 1, 2, 3, is what does the equals do? So if I say B is equal to A, and the key thing to remember here is this does not make a copy. What this has done is there's this one list sitting in memory somewhere, and it used to be that A was pointing to it, and now B is pointing to that same list. So there's one list, and they're both pointing to it. What you could tell, right, we do a little experiment. Oh, I'm sorry, I didn't really talk about it. How do you refer to an element inside of here? Just like in string. So if I say a square bracket 0, that's the first element. Right? So I can check my experiment by using this on the right-hand side. I'll say, well, I'll set A0 to 13. I'm going to change that first element. Lists are mutable. You can change them, unlike strings. Strings are the ones that don't change. So if I look at A, it's now different. B, it's different also. So this kind of shows how they were just pointing to the one thing. If you want to make mostly, just having the one list or whatever it is and having pointers sort of sprinkled through your program all pointing, sort of, I could say, sharing that data structure, for the most part, that's just totally fine. You shouldn't a priori try and block that out. I will show you how to make a copy, just if you wanted to. The way you make a copy, or actually I'll set B to be a copy of A, is the Pythonic way is use slice syntax. So if you say square bracket, colon, square bracket, that's the kind of Pythonic way of saying, well, here's a linear collection of things, please make a copy of it. So now B really is a copy, so if I change it, yeah, that's right. Yeah, so the question is, so before I made a copy, if I changed B, would it reflect an A? Yes. So there's this one list in memory, they're both pointing to it. They're literally sharing it. Now, and I'm getting to find those. As a practical matter for your Python programs, it's just not a problem. It's just fine. In C++ or in C, you would want to make copies mainly because of the memory management, like trying to know when to free, when to reclaim the memory. But Python, like any reasonable modern language, has a garbage collector. It just takes care of the memory collection. And so as a result, this need to make copies just kind of goes away. Or what I found transitioning from C++ languages to Python, copies, like the need to do that had just gone away. So I guess what I'm saying is, like, you may have an instinct to make copies, but I'd say attempt to keep in check. If you'll find you can just not make copies, and most stuff's just going to work fine. All right. So let's see, we got the square bracket, the length, the see what are A and B these days? Oh, they're the same. The equals does comparisons, just like the string. So you have two lists. It actually follows the lists and checks piece by piece if they're the same. So as before, it does a kind of an intuitive notion of checking. Now, what's the other thing we did lists, right? Or with strings, a little complicated, was slices. That works with lists as well. So here I've got this list. If I say A, I don't know what, 1:3 or whatever, I can pull a slice out of a list. So for maybe the most common case is like if I want to talk about a list except for without the rightmost element. So I'll wait till we get to the exercises. But yeah, you've got this very concise syntax for kind of talking about subparts of a list. All right, so let me show you the main syntax for this thing. So a very common thing to do, and actually I'm going to... So if I say for num in A, print num, then what that's going to do, the little dot there is just an artifact of the interpreter, just to let me know there's more output coming, so you can ignore that. So really what that did is it just looped over the list, and once for each element, it's going to run this body of code. And each time through, that value num is just going to be, a one element from the list. So this is it's the very common case. You just want to loop over the thing. It's sort of a for each. Yeah, question now. Well, so what it's doing is, so the question is, how does it know that num results from those numbers? What it's doing is num is just a variable name just chosen by me. It could have been anything. And what it does in the loop, essentially what it's doing inside the loop is like num is equal to whatever, kind of like what the next value is. It assigns it into num, just like the variable. And then after that, then it runs whatever little bit of code I have. And then it loops around and does the next one. So in other languages, you might use right here. So this is, for the exercises, this will come up a lot. The idea that you have a list of a bunch of things and you kind of want to do something for each one, that's a common case, and this is certainly the syntax you should use for that. There is a related syntax. This is the first one. The second one is very simple, which is just you have some value and you want it is in a list, and you can imagine, I'll write it up above. I'll put it up here. Stuck this here. If you want to check if a value is in a list, you can write it this way. You just put whatever the value is, and then the word in. Just the in by and whatever the list is. So if you've got, this works for lists. It actually works for a lot of things. Just in Python is this built-in way that you've got some composite data structure, and you want to tell, is this thing in here? So what's A? So for example, I could just write 2 in A. And that's just going to go over A, figure it out somehow, or what's something, I guess I could say the 14 in A. There's the false. So this is another one of these sort of higher the food chain things. You might have an instinct, I want to see if this is in here. I'm going to write a for loop, and I guess I'll loop through, and I'll compare each one with equal. In Python, it's just built in. You say, look, is this in there? It works for actually a lot of data structures, and in the hash table case, it's actually quite efficient. It does something smart, depending on what data structure you have. So you should not worry about doing something weird there. So along with slices, you should just, as I wrote earlier, you should just go ahead and memorize those. Those two syntactic constructs, very common. You should just know those. And of course, my examples later on. This will appear all sorts of times. All right, so let me show you. Just as with the string, we had methods like dot lower and dot replace and dot find, whatever. The list is the same way. It's got all sorts of built-in stuff. I'm just going to show you a couple. One is, and you can just guess what that does. Just puts it on the end there. One important thing about append is that it does not return a new list. It returns the special value none, which I know you saw in the starter code a little bit. None, uppercase N, I'll just type here, is sort of the null value. It means like nothing. So a.append returns nothing. What it does is list. So it does not, it would be wrong to write this. A equals a.append of something. I have to say, no. I mean, there is this form of the world where, some other language maybe that works, but in Python that just happens to not work at all. And it's because append does not return anything, it modifies the list in place. And that's, I've absolutely made that error myself. It's just there's these two different paradigms they could have chosen, and they chose the one that doesn't work. Alrighty, also, there's it's kind of the reverse of append. There's pop. And so if this is by position. So if I say pop 0, what that's going to do is it removes, it sort of pops off the 0th element and returns it to me, and it modifies the list. So it kind of removes it from the list and sends it to you. So if you want to kind of remove an element and just kind of get it out of there, then pop is sort of handy. And where? And then you should look at the docs. Yes, there are dozens of built-in list methods for all sorts of common stuff. And if you have a problem involving manipulating a list, searching it or replacing it or whatever, yeah, you should go find the built-in ones. There is a particular case though that I want to show you. There's one other one I'm going to show you, which is something I haven't talked about so far. So here is A. There's I guess this is an operator called del. and what delete. And what delete does, obviously it deletes, but in particular you can use it on a variable. So if I say del a, what that does is it kind of removes the definition of a from my local scope. Whereas when I had assigned a to 6 or whatever, that put it in there. So now, after that, if I try and use a, so it's kind of the reverse of the direction I showed before. It happens that del also works on lists. So if I say a is equal to 1, 2, 3, and let's say if I can square bracket 1, that's the 2, right? So it turns out you can use a del into a list. So if I say del of a square bracket 1, leads it out of the middle of the list, but now the list actually shrinks. So that's, I've showed you how to add, I've showed you pop. Well, so del's another way you can sort of put in there. Yeah, question over here.
Did you, if you've assigned A to B, for instance, without copying it, but actually pointing to C?
So this is one of these cases where I should just do it in the interpreter. Okay, so let's say 12, and I say A equals B. Okay, yeah, so if I del A, then B is still fine. All right. The del A, what it's done, it's just kind of removes, it's sort of like when I had A and B pointed to the list, right? It's like, well, the list is still there. Deleting A, I'm deleting the idea of A, but whatever it pointed to, something else might have been pointing to it. Now with the 12, my use of the word point there is a little inaccurate, but the basic pattern helps. Alrighty. So the most interesting thing with lists I want to show you is sorting. So there's this old way of doing sorting where there's actually a dot sort method on the list, and I want you to not use that one. I'm going to show you this newer, cooler way that it's just better in every way. And you could, all those dinosaurs who are using dot sort, you can just look down on. All right, so what I'm going to do, well, first I'll just show you the most basic case. So I'll set A equal to, 4216. So the simplest way to do sorting is there's a function called sorted. And you can feed a list into, and what it does is it makes a new list and it sorts it. Sorts it into increasing order. Now, so in this case, when I call it sorted on A, it's making this new list and then it's sorting it, in this case, we're doing a numeric sort. In reality, what's going on is it's the comparison in Python depends on the type of thing being compared. And in this case, it's a list of ints, and so when it gets down to the comparing one, see, it's like, oh, this is 2 ints, so I should do a numeric comparison. If instead I had a list of strings, it would have gotten down to comparison, would have seen, oh, I have 2 strings, and so it would have done a textual comparison. Again, it has that sort of Python quality of like, at the last possible second, it sees whatever the 2 types are, and it does something appropriate in that case. So one of the nice things about sorted, and actually I'll pull up the help page for sorted. Remember help? So if I say help of sorted, it's pretty tertiary. It says sorted of an iterable. So this actually works for a list. You can actually feed into sorted an iterator or some other things that kind of are capable of producing lists, although they are not themselves lists. You can feed those into sorted too. It just works with all lists. Anything that kind of looks like a sequence. So the syntax here refers to optional named arguments. And so this built-in, like, yeah, you can just not specify CMP or key or reverse, but if you do specify them, then you can sort of give it this extra argument. So this is a nice quality in Python. So in this case, I had sorted of A is that way. I can also say sorted of A, comma, and then one of the optional arguments is called reverse. I mean, I had to go look up and see that was the name, but I can see the name is reverse. And if I pass true for that, then it still sorts them, but I just get it the backwards way. So that's a very common problem, right? Is you just want it sorted the other way, and so that's just what. Yeah. Question. Yeah, so sorted makes a copy. It makes a new one and sorts that. Yeah. So for example, well, so here's A is unchanged, right? And here's sorted of A. What I could do, this is what you're suggesting, is I could say A is equal to sorted of A. Like, yeah, if I don't care to keep the original one, that's fine. So now it's just sorted. So you have the, whereas if it overrode it, you wouldn't even have a choice, right? So it's this way, you get to pick. Alrighty. So let me show you. So that's just like basic sorting. So now I want to show you how to do custom sorting in Python. And the Python syntax, the Python structure for this, I think, is really nice. But it's going to be a little more complicated. All right, so I'm gonna set up my case so it's exactly the same as the one in the handout. All right, so here I'm going to have some strings. So if I say sorted of A here, they're strings. By default, what I get is textual sort. Now, the problem I want to consider is, for custom sorting, right, you want to sort some other way, not just textually. The case I want to consider is, well, suppose I want to sort these by length. Right, I want the D first, and then the B's, and then the C's. Right, I want kind of increasing order by length, just as an example. How might I do that? Well, the old way to specify custom sorting in a lot of languages is that you write an argument comparator. You provide some function that takes two arguments and compares those two and returns either a negative number or a 0 or a positive number, depending on how you wish for those to be ordered, and then you feed that into the sorting function and it uses it. Anyway, that is a classic technique, the two-argument comparator technique. But it's a little messy, it's a little difficult to describe, it's just not that great. So Python, we're just not going to do it that way. Z. I'm gonna mix my problem up a little bit here. Let's say, how do I want to sort this last character in each string. I want to ignore all the other characters. This can be this is the sort of problem. This is a custom sort that you might solve with a key equals function. And I'm going to do it with a def, just like we've done. So I'm going to say def last of a string. I'm going to do this all on one line, which is not normal, but because I'm in the interpreter here. So I'll say def last of s. I'm going to say return, what is that, s of -1. see. Okay, now last is fine. So now if I say last just on its own, like, oh, well, that points to a function. Just like if I say len, okay, well, yeah, that's a function. I mean, one's built in and one's I just made, but it's still going to work. All right, so the last function, you give it a string and it just returns that last character. So now if I say sorted of, or so now I'll remind you what A is. If I say sorted of A, key equals just the thing I just defined, last. Check it out. So now I've done custom sorting, and in this case, what it's doing in the shadow list is it's just pulling out whatever the last, the minus one, whatever the last character is, and sorted by that. So there's a couple examples of custom sorting. Yeah, question.
Element in A was BB. Would it, or that's probably, yeah, it was BB. Would it double sort, like do the first sort by number of characters, and then within, if there were two?
I see, yeah. So I'm going to answer a slightly different question. So I mean, there's this idea of, well, what if I want to sort by one thing, and then I want to sort by something else? You know what, I can answer that more effectively when I've covered one more data structure. There is a way of doing that, but I'd like to just hold off on it. And it's a very reasonable question.
Would it just be random if you didn't use that extra thing you're going to show?
I don't think it would have worked the way you want, but what I prefer to do, I want to save time and show you the way that does work. And then then we can talk about it. Okay? I'm sorry, that's very unsatisfying, but there's this other data structure we really need for this. All right, so I understand. I think the sorted thing is one of the more difficult things to kind of get your head around. But yeah, predictably, the exercises have like a bunch of custom sorts, and it's a very powerful technique. So I'd say hold off on that, and then I do have this beautiful art in the handout to try and follow. So just hold on with that. On the next set of exercises, will be pretty soon. You'll get a chance to play with that. All right, so let me show you just a couple other things with the list. So one, I'll stick with A just as these strings. One fairly common thing to do once you've got your program and you want to now produce your final output is you want to make a string out of a list. And so like one thing you might do is maybe loop through this list, right? I could type for S in A colon and kind of print each element or something. It turns out that's okay, but there's a built-in that just takes a list and sort of concatenates or whatever all the parts of it together just in one step. And so that's such a common operation, it's nice to know. So for example, if I were to say, so this is called .join. So if I were to say colon .join of A, what it does is it just puts it all together in one string just in one step. And so it's a little unintuitive, but actually the case I use most often is \n. Like I say new line .join, and then really I've now got one per line, but just all in one step. And then I can just print that in one step, or write it to a file or whatever. So that is a handy one to know. I'll switch back to the colon one. So going the other direction, there's also a split. So actually here, I'll say B is equal to that. So now B is the string I'll put together. If I say colon dot split on B, oops. Was that wrong? Oh, I'm sorry. That's the other way. Sorry, B dot split on the colon. So you have a string, you call dot split, and you say here's essentially the delimiter. Then it kind of explodes it out, so you can recover the original list. So split. Now, these are not really intellectually deep, but it just happens to be a common case. So those are handy to know. Oh, I should mention those are not regular expressions; those are just substrings. We'll do regular expressions tomorrow. Yeah, question.
Which is like, if you're going through a list of data and you're making a list, here you're just defining this. But
Yeah. Here, so let's do a little example like that. Yeah. So the question is, how do you kind of one pattern that shows up in the exercises, or like let's say I've got A here, and I want to loop through this, and I want to pick out some of them and put them in some other list. A pattern might be like this, where I'll say a result is equal to the empty list. The way you would do that, I'll just add them all in this case. But I'm going to loop through, and I want to put some of this. I would just use append. So I'd say result dot append of S in this case. So now if I look at result, I mean essentially what I've done is I've just copied all the elements over. So in terms of that is a common pattern. You start with empty list and you kind of put some stuff in it.
like to say you're document data or whatever.
Yeah.
You don't have any list here. And you're starting your for loop.
Yeah. All right. So the question is, what if you have documents? Or I mean, essentially, what you're getting at is kind of realistic. And the trick is, I I'm going to show you how to open files and read text out of it, and then I think at that moment I want to answer this question. But yeah, thus far I'm just doing lists a little bit. I haven't done that yet. Alrighty. So the last thing I'll show you is just sort of, for completeness, I haven't showed you like a traditional for loop, like I equals 0, 1, 2, to the, like in C or JavaScript, you might do that all the time. Mostly the ones I've showed you, these techniques just cover it. However, I will show you how, if you want to count over a bunch of numbers, the way to do that is there's a function called range. And what range does is it's sort of on, if I say range 20, it sort of on the fly appears to build this list, starting at 0 and running up to, but not including that number. So if you wanted to count from 0 to 19, you could say for I in, and then call range to kind of on the fly make this list appear. And so that would be a way. Now there's a little bit of a difference between Python 2.4 and Python 3. Whether is that list really created in memory or is it kind of fake created? The more modern versions just fake created, or which saves memory. So you should not worry about that efficiency detail because the more modern versions are just all over. Now I've showed you just the most simple case of calling range argument, but in fact you can specify the starting number and the end number, and should it go by fives or all those kind of when you give it more optional arguments. So if you wanted to generate a series of numbers, you could. That would be good to do it. There's also a while loop, which I'm just not even going to demonstrate, but yeah, it works like while loops in other languages. The most common case, though, is the one I showed you, just the for loop to loop over a question. The last thing I'll have to say about the for loop is that it does have this constraint, which is when you are looping over a list, you cannot modify that list in a way which changes its length or structure. So you can't add an element. It kind of makes sense. If you add an element in the loop, like you can kind of get this weird infinite structure. So do not modify while iterating over. Interestingly, Java has that same constraint. So there's an implementation reality underneath there. Alrighty, so we're almost ready for another exercise. The last thing I want to show you is the tuple. So I showed you strings, was surrounded by quotes, lists, surrounded by curly braces. The tuple is actually, it's a modest little data structure, and it looks like this. Tuple is put in parentheses, and it has commas inside to separate the elements. So a tuple, now a list can grow and shrink, right? It can start at blank 0, and I can append, put stuff in there, delete, whatever. The tuple is fixed size. You create it length 3, it's length 3 forever. In fact, it's immutable. You just can't change it. So what the tuple is good if you have some fixed number of items. Like let's say you want to store an x, y, z coordinate in three-dimensional space. Right? There's never going to be a fourth number. It's these three, I want to lock them together. Tuples are good for that. Or let's say you have a URL and a score. And it's these two things. It's like, I want these two things to go together. In Python, you can put those in a tuple length 2 and then store that in a list or return it from a function or whatever. So the tuple is the kind of anonymous way of taking a fixed number of things and just kind of locking them together so that you can pass them around or store them. And in the later exercise, you'll see some examples of those. So I'll assign A to this tuple, I guess. And then, kind of like you could guess, I make this claim that Python's all consistent. So how do you suppose you tell the length of a tuple? Of course, it's len, right? And how do you pick an element out? Yeah, it's square bracket. So all that stuff, list, strings, pretty much works for tuples as well. The one difference is the tuple is immutable. So if I say a square bracket 0 equals 13, I try and assign into it, that's kind of bad. Right? So the tuple can't be changed. Once you create it, it's like a string. So tuples and strings, immutable, lists, mutable. So there was a question earlier about sorting. And it turns out if you want to sort by one thing and then sort by another thing, the best way to do that is with tuples. And so I think I could do a short example here. So I'll say 1, comma A, comma. So I'm making a list of tuples here. Oops, okay, well, let's make that E. And then we'll make this 2, comma A. So the way it's going to work is if you sort tuples, just the natural under-the-hood sorting, what it does is it first compares the first elements of the tuples. And if they're different, it just sorts by that. But if those elements are the same, then it goes to the next one. So here, now I need to make this, I say 1A. All right, so what I've made is a list of tuples. And to show this off, I think if I do sorted on that, where the first numbers are the same, it goes sorted by the AB, and then this one is last. So this is a little bit of a detail. It's not something I hadn't planned on mentioning this, but for the question back here, if you wanted to sort on one thing and then sort by something else, what you could do is write your key function to return a tuple. And then by whatever you put in that tuple, you can get the behavior you want. Put the thing you want to sort on first as the first thing, and then a comma and whatever the second thing is, and then it'll just automatically go to the second thing if the first thing is the same. And that's just built-in Python sorting. Like it gets how to sort tuple stuff in. Alrighty. So one other thing I have to show you with tuples, this is kind of a, dare I say, kind of a Perl. I think it was sort of a Perl feature. Is that if you say x comma y, there's the special thing with assignment. You say x comma y in a tuple equals 1 comma 2. What it does is kind of a parallel assignment. So now x is 1 and y is 2. Not super common thing to use, but it does show up now and then. Okay, now that's all. There's some other stuff that I'll show you later about that. Alrighty, so what we've seen really at this point, what I'll take in is lists, how to loop over them, and then dot append and whatever, and sorting, and a little bit about tuples. So what I would like you to do is take a look at, there's an exercise, a question? Yeah, slicing works with tuples. So what I'd like you to do is take a look at the exercise list1.py. This is going to involve doing basic stuff with lists, and also a little bit of custom sorting. As before, if you're just so unbelievably fast that you finish those, then there's a list2.py, but mostly I'm just hoping people can get at least some of the problems done in list1.py. And what I'd like you to do is work on that, I'm going to say for half an hour. So I'm going to pull you guys back here at 2:20. I'll do a significantly bigger exercise till I finish up. Yeah.
Okay, my friends, thank you so much for being with me as we went through that part of the exercise, and then we're now looking at lists, and so we can sort of see what is going on here as they kind of give us back to these exercises. So this is something we'll go through.
All right, sorry to interrupt you. I see a lot of people.
Okay, so this is something that we can visit and just kind of, sort of review, like what are the difference between strings and lists, and we have those exercises, and so it moves on. There's sorting, Dixon files, regular expressions, utilities, and so we'll continue also going through the videos until we get through the end of it, and we will also, by the end of it, have looked at all of the exercises, and we'll go through them. So there's a string exercise, the list count, and the word count. And then there's a baby name exercise, a copy special exercise, a log puzzle exercise. So by the end of it, we should get proficient enough to be able to do these exercises together and figure it all out. And also want to take a look at what we think about what we're going to think about our different interpreters and which ones we're going to select, so we can chat about that as well. So I look forward to seeing you again tomorrow at 9:30 a.m. Pacific, 12:30 p.m. Eastern, or whatever that translates to wherever you are at. I thank you for joining me. I didn't have the chats turned on. I'll look at them and see if anybody has joined. Again, I'm not promoting these streams right now. I've got, hi, I have someone saying hello, hello, hello. I don't know if you're still here, but if you are, I welcome you and I thank you for joining me. I have not promoted this at all. I've had so many technical issues in just understanding the OBS software that I've just begun. And so I figure as I get better both at streaming and of learning how to learn this together, I have identified probably thousands of resources to share across. And so the things that I'm very committed to learning this year are Python, RStudio, Tableau, SQL, Advanced Excel. Not necessarily in that order, but that's kind of what I'm going to be kind of looking at, and just general data science, data mining, data cleaning. My goal is to really get good this year at data visualizations. Also, I mean, probably the one I should be mentioning first and foremost is I'm a grad student learning Python. No, sorry, Python. I'm a grad student learning ArcGIS Pro. Is one of the main softwares that we're being introduced to. And I think that one of the challenges I'm having with the program is it's so focused on Esri products that I'm missing, and I feel like spatial data sciences is on one side and data science is on the other side. So I've decided to sort of self-study the data science piece because it's not part of my academic curriculum, but most of the jobs that I'm most interested in, the work that I want to do, is at the intersection of both the spatial data science and the traditional data science. So I am doing as much as I can within my academic program and also within my own interests in being able to learn this and really learn together, because I really want to sort of share that although I have although I have a bachelor's, I have a master's in urban planning, I'm pursuing a second master's. It's like we all start at the beginning. It's like learning can be fun, but learning can also be uncomfortable. I think that's the point of it. And I just always want to sort of wrap with like, whenever you encounter something that's difficult or challenging, bless it, because it just means that if it were easy, everybody would do it. And so you actually, when you kind of get through it and you figure out the learning objective, and everything's learnable. Everything is learnable. It's just finding the right resources that speak to you and help with whatever like you're getting stuck on. I remember trying to find out resources to help me figure out how to like do the layout of my map, and I just couldn't figure it out, and the things that I was seeing just weren't clear. I finally just asked my professor, and she was like, "Oh, it's this and this," and I was like, "Oh, thank you." So sometimes it's just literally just asking someone to sort of point it out to you. If the resources that you're finding aren't as clear, but just keep at it until you kind of get it. And also understanding like what is your interest and what are you passionate about, so you're seeing real world applications for what it is that you're learning. So for me, one of the basic reasons to learn Python is that it integrates with ArcGIS Pro. I don't know how yet, I don't know what it does, but I figure if I can sort of get the basics going of Python, then I can actually like kind of start putting those two together. ArcGIS Pro also marries to SQL and databases and things like that. So I definitely want to learn how to, again, get those data sets, pull them in. I have a general, like, basic understanding of RStudio, and I'm definitely going to revisit that. So my thinking here is I don't know how long each of these are going to take to sort of get sort of a working proficiency in, but as I do get a working proficiency in, I'll probably sort of move on to the next one. So the main goal that I have right now is to be able to just get a working understanding and basically get started and get each of these programs sort of installed on my computer, and just like, and a lot of data science, as I'm saying it, like the terms and the ideas, they cross over from platform to platform to platform. So they build on each other. So to me, that's why it really doesn't totally matter where you start. But the idea is, I don't know if each of these is going to be sort of 4 to 6 weeks. I think each of them is going to be at least 4 weeks that I'll sort of say, okay, now, or maybe 6, just depending on sort of which courses we identify. So like, okay, now we're on Python. Okay, now we're in R. Okay, now we're in Tableau. Okay, now we're in SQL. Now we're in Advanced Excel. So those are kind of the ones that I definitely want to be looking at. Also, the other ones I want to learn, which are a little bit out of sort of computer science, but are design tools. So the other ones on my list for this year are getting proficient with SketchUp and also with ArchiCAD. So I would like to be able to know that I can go in and do design work And then other softwares, just because as a content creator, I want to actually figure out how to use OBS and get really good at OBS. I have the Adobe Creative Suite, so I'd like to kind of learn how to use better editing tools. And I'm also learning languages, and that's my evening stream, is I focus on my support for Ukraine and just learning more about history, culture, language, and sharing current events as I see them, and other stories that I think are relevant in support of Ukraine. So that is it for today. Thank you for joining me. Thanks for coming by and saying hello. And we will continue on this journey, and I will have the link to this Python course in the video, so you can check it out yourself. All right, have a great day. See you tomorrow.